Hello students, today we are going to discuss some important structural formula of organic compounds, how the organic compounds can be written in different forms, what are the different structural formula of organic compounds which is very much essential for representation of organic compound. Different questions are framed using different structural formula of organic compounds, so you should have some better knowledge regarding the structural formula of organic compounds. So organic compounds can be written in different structure. First we can write this one, that complete structural formula using complete structural formula. Complete structural formula generally, here suppose example ethane. If you write ethane can be written as like this. This is called complete structural formula, showing all bonds present in the molecule, all atoms showing different bonds represented in the molecule. That is called complete structural formula. This is, suppose ethanol can be written as this is represented as complete structural. That means you have to draw the structure showing all bonds attached to the atoms, particularly in the carbon chain. Then it can be written as condensed formula, condensed formula. Condensed formula means here you have to write the molecule combinedly. For example, ethanol can be written as C2H5OH. This is the condensed formula. Or it can be written as that CH2OH. This is also condensed formula. This formula is also condensed formula, and this condensed means you have to combinedly write the molecules. This is called condensed formula. Okay. Then third type is using bondline formula. Bondline formula means only showing bonds. For examples, here that propane, let it be propane. Propane, you can write here the carbon atom in the chain will be represented at each corner. For example, propane has 3 carbon. It is represented like this. One downward and verticals like this. You have to draw the structures downward and upwards, and showing when it will be the line will be bent. The bent position show the carbon atom. So this is one carbon atom, this is your carbon atom, this is also carbon atom. Here in the bond line formula, not necessary to write the atoms, mainly hydrogen atoms and carbon atom, not necessary to draw. This is the structure of propane. For example, propanol. Propanol mainly contain 3 carbons, like this, 3 carbons, and the end carbon contains OH group. This is the structure of bond line formula of propanol. Here 1, 2, 3 carbon and OH group. So, and this indicates CH3. This end carbon, this is CH3 form. Not showing CH3, only single line. Okay. And you showing double bond also you can draw. Suppose propene. Propene means any position you show double bond. This is your propane. Okay, this type of structure that is called Bondline formula, only showing bonds without representing the atoms, without showing the atoms. So this is Bondline formula, condensed formula, complete formula. Then important structure is, that is 3D representation, ball and stick model. Ball and stick model. Ball and stick model means you have to show here what happens. Suppose your methane, let it be methane, CH4, can be written as in 3D, in three-dimensional form. Here this is your carbon atom, hydrogen atom will be shown like this. Okay. Like this. This is ball and stick. Ball and stick, using stick means bond. Here stick indicates bond, and this is your central atom, this is the bonded atoms. Ball and stick models. It can be also represented as framework model also. You can draw framework models. In framework model, what happens? You have to show only that center at this center indicates the central atom, and here the stick will be, okay. Here what happens? Framework model. That means here that different structures, here the first part is black and the upper part is white. That indicate two parts. That indicates framework models. Same, it is a structure of methane. And sometimes you can draw like space filling models. You can draw also space filling models. In space filling models, here what happens? You have to take 3D diagram, that you have to draw one molecule, that's atoms, and it will attach to different bonded atoms. Okay, this is your bonded atoms. Okay, here space filling model, that means that some spherical shape atoms will combine each other and forming space filling models. That means here the whole molecules represented by spheres, central spheres, and these are the bonded spheres. Bonded sphere, bonded atom, central sphere is the central atom. Okay, there is 3D expression, that is space filling models, and it can be also wedge and dash formula, also 3D model. Wedge dash formula. In wedge and dash formula, you have to draw like this, that central atoms, this is your bonded atoms, this is your one bond, and another bond is showing like this. This is solid. One bond will be solid, another will be dash. That is a dash. This structure, this indicates away from the viewer. Away from the viewer. And this indicates towards viewer. Towards the viewer. Towards the viewer, and this is away from the viewer. Then you have to watch the molecule. One bond, it will be away from the viewer. It will be away from the viewer, and it towards the viewer. Towards the viewer, away from the viewer. That means indicates this is one plane, it is another plane, these two in one plane. These two structure, this hydrogen in one plane, and the dash This is called wedge dash. This is the solid dash. This solid dash, solid wedge. This is called solid wedge. This is also called dash wedge. Dash wedge indicates away from the viewer, and solid wedge indicates towards the viewer. It is one plane. This is another plane, and another two is one. So 3 planes. This is the 3D models, that is towards the viewer, away from the viewer, and it is one plane. These two, suppose in the board, these two atoms in the board, and this is towards the viewer, and another one is away from the viewer. That is back side of the board, another is front side of the board, and these two on the board. So this two one plane, this another two dash, and dash and wedge both in different plane. This is called wedge and dash formula. This is also 3D representation. Another important representation of the molecule is Sars formula. In the Sars formula, what you have to, suppose example ethane, suppose C2H6, let it be C2H6 ethane. Here the whole molecule divided into 2 parts. Here the first carbon, that is one will be upward and downward. One carbon, when you select two atoms, as it is organic compound, you have to you select the carbon atoms. So one carbon will be above, another will be below, but the top carbon will be just towards right, and the bottom carbon will be towards left, and it will be bent. It will be drawn in just top to bottom, and one will be towards right, other will be towards left, and the molecule will be viewed from bottom. It will view bottoms. So the atom will be written like this. Suppose this is your hydrogen atoms, and this is your hydrogen atoms, then this is your hydrogen atoms, this is your hydrogen atoms, this is your hydrogen atoms, and this is your hydrogen atoms. That means you have to consider the molecule in 2 parts. The bonded atoms, all bonded atoms attached to the 2 carbon atoms. One carbon atom will be upside, another will be down, and the upside carbon will bend towards right, and the bottom carbon will bend towards left. So it will be bent, not straight. It will bend towards right, and the bottom will be towards left, and the top will be towards right. And the bonded atom will be drawn in 3D forms, so that the name of the formula of the particular structure, Sars structure, can depends upon the arrangement of bonded atoms. It is fixed. Top carbon and bottom carbon always fixed. Only the bonded atoms will be varied. Depending upon the arrangement of bonded atoms of 2 carbon atoms, the name of the molecule will be given. So you just remember, this is the one representation of Sars formula, showing the whole atoms into 2 parts, top carbon and bottom carbon, and all bonded atoms and groups attached to the 2 carbon atoms, upper carbon and bottom carbon. This is called Sars formula. We will discuss in the next that lesson what is the types of Sars formula, what are the different representation, we will discuss later. Just you remember, this is one formula, Sars formula. Another important formula, that is called Neumann projection. In a Neumann projection, what happens? The whole molecule represented in the paper, in the plane, similarly in 2 parts. You have to look the molecules in such a way that one carbon will be front and other will be back. Generally, the front carbon will be represented as point, that is as a black spot at the point, and the back carbon will be represented as the circle. This is your back. This is your back and this is your front. This is your front carbon and this is your back carbon. Okay, so the bonded atom will be attached to this back carbon and front carbon. How? Just example, ethane, same example. Let it be, I will draw here. Suppose this is your ethane is C2H6. So this is your front carbon. Here the bonded carbon will be represented, it will be arranged in 120-degree angle. The angle between the two bonded or three bonded atoms will be 120 degree, and here the back carbon, this is your back carbon. For the back carbon, the bonded atom will be also same, just touching from the circumference like this. Here what you see the difference? Here what happens? This is your front carbon. This is your front carbon. This is your front carbon and this is your back carbon. And the bonded atoms will be attached to the front carbon from the center. Front means from the center, because the carbon valency is how much? Valency is 4. So this point and circle both indicates a carbon. It is a carbon, it is also carbon. So carbon already attached. Carbon already attached. You have to look the molecule from in this way. So this is front and this is your back. So front back already connected, and front contains remaining 3 atoms and back also contains remaining 3 atoms. So the back means it will start from the circumference. The bonded atom will start from circumference from the back carbon. This is your back carbon and this is your front carbon. Point indicates front carbon. Front carbon means atom will be attached to the center. The bonded atoms and groups attached to from the center mean this is the front carbons and the circle indicates back carbon. So this is this type of representation. It has also different names, we will discuss later. And this type of representation is called Neumann projections. So molecule can represent different structures, so that it will be easy to convert from 3D molecule to planar form or planar molecule to 3D form. So planar molecule can be converted to 3D. This is a planar representation and this is your 3D representation. 3 means wedge and dash formula. So like this, you have to remember what are the different structural formula of organic compounds. You have to remember, and these are the very easy way. Generally we are using complete condensed formula, complete structural formula and condensed formula, bondline formula also. In the bondline formula, sometimes molecule in the cyclic structure represented as a polygon form. Also this thing is right, this is last polygon formula. Polygon formula. In polygon formula, what happens? Molecule will be represented only in polygon form. That means without showing the atoms. For example, already I have told you in the previous, and this one, this indicates what? Cyclopropane. It is also one formula, that is cyclopropane. Cyclopropane. This type of molecule, then we can say that it may be alicyclic or that alicyclic or aromatic maybe. Polygon formula, this is also benzene. This is also benzene, polygon formula. So like this, different formula can be represented of the molecule. If the molecule is showing in cyclic form, in different polygon form, that is called polygon formula. Each corner indicates carbon. Maybe different atoms may be connected. If different atoms connected, that is heterocyclic. All are cyclic compound, and showing in polygon form, that is called polygon formula. So these are the some simple idea, some simple concept regarding the structural representation of organic compounds. How can you represent organic compounds? How can you write the organic compounds in different structures? So we discuss regarding this. different structural representation of organic compounds you practice. It is also essential for your higher class. Okay, thank you all.